LeetCode question number 126. Word letter the second. This is a hard question. Let's get into it. Given two words, begin words and end words, and a directory words list, find the shortest transformation sequence from begin word to end word, such that only one letter can be changed at a time. 2. Each transform word must exist in a word list. Note that begin words is not a transformed word. Note: return an empty list if there is no such transformation sequence. All words have the same length. All words contain only lowercase alphabetic characters. You may assume no duplicated in the word list. You may assume begin word and end word are non-empty and are not the same. Okay, let's check with example 1. Begin word is HIT, end word is COG, so we can go to HIT and then go to HOT and DOT and DOG and last COG. This one. And the second one is go to HOT and LOT, go to LOT and LOG and COG. So we need to return that. How we gonna do? Today I'm gonna use the BFS, Breadth First Search, to traverse word list, because BFS is good for find the shortest path, and then second, I will traverse to change the character one by one. So first I will change the first letter to A to G, and then next I will change the second is A to G, and then last T is the A to G, and then if they are the same as the word list, I will go to that node. That is the next node from the begin word, and then I will do same step again and again to find the end word. After I find the end word, I will put it to output, and then we need one more edge cases, because we needed to put only the shortest path only. So every time when you add to word list, we needed to check the short list. So at that time I will check the hash table. Key is the character, and then value is the length, current the stored. So if the new path is the smaller path, shorter than previous one stored in hash map, and then I will replace it. Okay. Okay, so first, I will get example 1 to explain. So first I need to queue, so I will use collections DQ. So first I need queue is collections DQ, and I need to ABC alphabet character ABC D E F G H I J K L M N O P Q R S T U V W X Y Z, and then I will put Q append. I will put the tuple. First item is begin word, and then second is first is word, and then I will put second is path. Then I will the initialize path is begin word array, and I need the output to return while Q is not empty, I will get word and pass from Q. And if word is same as in the word, and then I will output append path, and then I will skip the next code. And next is I needed to, if the word is not in the word, we needed to find the candidate. So okay, let's make the candidate for I in range len words, and then for character in ABC. Okay, now we can make candidate. Candidate is the first word I plus character plus word I plus 1. Each mean is first is 0, so okay, let's check with the begin word. It's HIT. First candidate, if I is 0, and then word I0 is that there are nothing, right? So candidate is nothing plus character. Character is the ABC, so first is A, and then words I plus 1. I plus 1 is 1, so IT. So start with AIT. Next must be BIT, CIT, DIT, EIT, FIT, to GIT. That is make sense. So that is candidate. After finish run, we changed HAT, BT, CT, ET. Finally, A, B, C. So if candidate is in word list, but word list is array, so when it executes this line, it will take big O-N. So okay, let's make it more fast. If we change this, we needed to word set, and then that is set word list. So now we can access O1. And then next, we needed one more thing. Is visited. Yes, we make the hash set. Key is first is begin word. Length is 1. So candidate is word set. So if it not in visited, or if even the visited, the length of path is the smaller or equal than visited candidate. That means stored one is much longer than current one. Then we needed to replace, because we needed to return shortest path. So in this time, first I will need to update visited to the smallest path length, and then I will append candidate with path plus it. Okay, I have question to you. If should we change this code to like this? No, it cannot. What is different with this one and this one? Yes, this one is first we need to update the path, but this time we didn't update the path. Just to send the argument is path plus candidate. So this one is did not change it. And then while we the DFS traversing, passes must be not changed, because Otherwise, when you do go back, the path is the dirty, changed. So it will make wrong output. And then we finish that. We turn off. I think almost done. Let's check. Okay, looks good. Okay, even we pass, the runtime is very not good. So, okay, let's make it a little bit better. Okay, our problem is that we, when we make the candidate, we use too many CPU cores because we change A to G, A to G, A to G. Can you make them more faster, a little faster? How about use the graph? Okay, how about, okay, let's say if we make this one graph, and then graph is like this. First is IT is Deoran YT. HT, this one is HOT, and then OT is HOT, DOT, LOT. If we make this one, we no need to generate all of the possibility of character. Just we check the inside of one word list. Then maybe we can make it much faster. Okay, let's change up this. To do that, we need to make generate graph. At the time, I think ABC and word list is no need anymore. So let's make the graph, and I will use collection default dict because I would like to initialize list without any action. And after that, let's make a graph. First, word in, word list, and then for get index from words to generate candidate, length word, and then keys candidate keys must be this one, and then change this one is asterisk, and graph key append word. Then now we can make we got this graph, and this one is same. We can use this one also again. This okay. Maybe we need to change this part character ABC. This one is no more need. So now for candidate in graph, maybe we can change it on that, and then we also use this one, right? Word I, and then this one is key same as this one, right? Then we can get candidate, and then when we get candidate, we can use this one. Let's check the code. Okay, looks good. Okay, let's check how faster than before. Wow, maybe 4 times faster than previous, right? Okay, let's check the complexity. Time complexity, okay, let's say length of word list is n. At that time, time complexity, this is n. And Q also used n, right? Only used the same as this one. And then, but in this case, the range of length word, so you need the length of word is n, is the m multiply n. Means time complexity is m multiply n. And then space complexity also m multiply n. Thank you.